Think you know the whole story? Turns out you were probably taught the half-truth. Welcome to Half-Truths. I want you to think back to your elementary school science class. Picture the room. Maybe there's a slightly dusty skeleton in the corner, a poster of the solar system on the wall, and that distinct smell of chalk dust, floor wax, and youthful curiosity. And somewhere in that room, probably laminated and taped to a cinder block wall, is a diagram. It's a simple, friendly-looking cartoon of a human tongue, sectioned off into neat, color-coded zones. You know the one I'm talking about. The very tip is labeled sweet. Just behind that, along the front edges, are the zones for salty. Further back along the sides is the home of sour. And then, across the very back, a formidable wall guarding your throat, is the domain of bitter. It was simple. It was definitive. It was science. We learned it as gospel. Maybe your teacher even had you do the experiment, dabbing a cotton swab dipped in sugar water on the tip of your tongue, then salt water on the sides. You'd nod along, confirming the neat little map. This is how we taste. The tongue is an organized sensor array, each region with its own specific job. Sweet things trigger the tip, which is why we lick an ice cream cone. Salty potato chips hit the sides. A sour lemon makes the back of your jaw tingle. And the bitter taste of medicine is detected at the last possible moment, a final warning before we swallow. This idea is everywhere. It informs how sommeliers tell you to roll wine around in your mouth to appreciate its full profile, hitting all the different zones. It's referenced in cooking shows, food blogs, and probably 1,000 family dinner table conversations. The tongue map is one of those foundational pieces of knowledge we collect early on and rarely, if ever, question. It's just true, but what if that story, that neat and tidy map we all memorized, isn't the whole story? What if it isn't even a true story? What if the idea that your tongue is divided into 4 distinct taste zones is one of the most persistent and successful myths in all of modern biology? Today, we're unlearning the tongue map. We're going to peel back the layers of this half-truth to discover where it came from, why it's so stubbornly stuck in our heads, and what the far more incredible reality of our sense of taste actually is. Because the truth about flavor is a story not about maps and zones, but about a symphony of senses orchestrated by the most powerful organ in our body, our brain. The story we all know is comforting in its simplicity. Our sense of taste, one of the 5 gateways to the world, can be neatly organized. It makes biological sense, or so it seems. Different tastes serve different evolutionary purposes, so why wouldn't the body dedicate specialized hardware to each one? Sweetness signals a source of quick energy, like ripe fruit. Saltiness signals the presence of sodium, a crucial electrolyte for our bodies to function. Sourness can indicate spoiled food or unripe fruit, and bitterness is our built-in poison detector, a warning sign for thousands of potentially toxic plant alkaloids. This framework is elegant. The placement of the zones even seems to tell a story. Sweetness is detected first, at the very tip, an immediate reward. Bitterness is detected last, at the very back, giving us a final chance to spit out something dangerous before we swallow. It's a perfect design, a testament to the elegant efficiency of evolution. This narrative is so powerful that it has endured for over a century, passed down from textbook to textbook, teacher to student, parent to child. It also gives us a language to talk about food and drink. The map provides a physical anchor for abstract concepts. When a wine expert describes a sip of Cabernet Sauvignon as having a sweet fruit-forward note that gives way to a more acidic mid-palate and a slightly bitter finish, they are, consciously or not, taking us on a tour of the tongue map. Tip, sides, back. We can almost feel the journey of the liquid over these supposed zones. The map gives us a sense of control and understanding over a profoundly personal and subjective experience. Its persistence isn't just due to classroom inertia. The myth supports a whole ecosystem of marketing and expertise. Think about a high-end coffee tasting. You might be instructed to slurp the coffee in a specific way to aerate it and ensure it coats your entire tongue. The implied reason? So you can activate all the different taste zones to perceive the coffee's full complexity, its bright acidity, its rich bitterness, its subtle sweetness. The tongue map provides a seemingly scientific justification for these rituals, lending them an air of authority. It makes the complex world of flavor feel conquerable. If you just learn the map, you can become a connoisseur. But there's a tiny nagging problem with this entire beautiful story. It's built on a foundation of sand. In fact, if you try the experiment yourself right now, you'll feel the first crack. Go on, imagine it. Think of the saltiest potato chip you've ever had. Where do you taste that salt? Is it only on the sides of your tongue? Of course not. You taste it instantly, everywhere, but perhaps most intensely right where it first makes contact. The tip of your tongue, the supposed sweet zone. And that is where our journey into the truth begins. The thread we need to pull to unravel this entire myth leads us back to the year 1901 and to a German scientific paper titled Zur Psychophysik des Geschmackssinns, or in English, On the Psychophysics of the Sense of Taste. It was written by a scientist named David Hanig. And ironically, Hanig never set out to create a map of exclusive taste zones. His goal was something far more subtle. He wanted to measure the relative sensitivity of different parts of the tongue to the four known tastes of his time: sweet, sour, salty, and bitter. He meticulously tested subjects, applying stimuli to various parts of their tongues and recording the lowest concentration at which they could detect each taste. His findings were not revolutionary, nor were they presented as a map. He simply created a rather complex and an interesting graph showing that, yes, there were minor variations in sensitivity across the tongue. The tip of the tongue was slightly better at detecting sweetness. The back was slightly more sensitive to bitter compounds. But, and this is the crucial part that history decided to ignore, these were subtle differences, not exclusive domains. Every single part of the tongue he tested could detect every single taste. Hanig's paper was published, and for decades, it sat in relative academic obscurity. It was just one data point among many in the ongoing scientific exploration of our senses. The myth of the tongue map wasn't born in 1901. It was born 41 years later, in 1942, through a fatal act of scholarly misinterpretation. The culprit was a man named Edwin G. Boring, a prominent experimental psychologist at Harvard University. Boring was writing what would become a hugely influential textbook, Sensation and Perception in the History of Experimental Psychology. In it, he decided to revisit Hanig's old data. But instead of reproducing the nuanced, messy graph showing subtle variations, Boring made a fateful decision. He simplified. He took Hanig's findings of slight relative sensitivity and transformed them into a hard and fast diagram of distinct, segregated zones. He essentially took a mild suggestion in the data and turned it into an absolute law. His simplified, easy-to-reproduce diagram showed a tip that tastes sweet, sides that taste salty, and a back that tastes bitter. Why he did this is a matter of speculation. Perhaps it was an honest misreading. Perhaps he felt the simplification made the concept easier to teach. Or perhaps it was just a quick way to create a visual aid for his textbook. Whatever the reason, the damage was done. Because Edwin Boring was not some obscure scientist, he was an authority from Harvard. His textbook became a standard, and his drawing of the tongue map was treated as fact. It was copied, reprinted, and disseminated into encyclopedias, magazines, and most importantly, science textbooks for schools. The diagram was a teacher's dream. It was visual, easy to explain, and came with a fun hands-on experiment that seemed to confirm it, as long as you weren't paying too close attention. For generations, students like you and me sat in classrooms, looked at that colorful chart, and accepted it without question. The myth had taken root, not because of a grand conspiracy, but because of a simple, compelling lie born from a lazy interpretation of old data. It wasn't until the 1970s that other scientists began to seriously re-examine the claim. Researchers like Virginia Collings confirmed what Hanig had originally found. While sensitivity levels do vary slightly, all tastes can be perceived anywhere there are taste buds on the tongue. By then, however, the myth had a 50-year head start. It was already a laminated poster on the wall, a fact everyone just knew. So, if the tongue isn't a map of 4 distinct countries, what is it? The reality is far more democratic and infinitely more complex. Your tongue is covered in little bumps called papillae, and nestled within these papillae are your taste buds, thousands of them. An adult has anywhere from 2,000 to 8,000 taste buds, and they aren't just on the tongue. They're also on the roof of your mouth, in your throat, and even on your epiglottis. Now here is the key to dismantling the myth entirely. Each one of those thousands of taste buds is like a multi-talented chemical detector. It's not a sweet taste bud or a salty taste bud. Instead, a single taste bud contains a cluster of 50 to 100 taste receptor cells. And within that single cluster, there are different types of cells specialized to detect each of the 5 basic tastes. Yes, 5. The old map didn't even have all the information. The 5th basic taste, officially recognized by the scientific community in the 1980s, is umami. It's the savory, meaty, brothy flavor you get from things like soy sauce, Parmesan cheese, and mushrooms. It was identified by Japanese chemist Kikune Ikeda back in 1908, but it took the West decades to catch up. So, imagine a single taste bud as a tiny tasting committee. One member of the committee raises its hand and says, "I'm detecting sodium chloride, that's salt." Another says, "I'm getting sucrose molecules, that's sweet." And a third chimes in, "I'm sensing glutamate, that's umami." All of this information, from every taste bud all over your mouth, is sent via nerve pathways up to your brain. It is your brain, not your tongue, that processes these signals and creates the unified perception we call taste. There are no zones. There are no borders. There is only a constant stream of chemical information being fired from all over your mouth to your brain for analysis. But even this picture is incomplete. because the signals from our taste buds are only one small part of the story. The half-truth we're dissecting isn't just that the tongue map is wrong. It's that the entire concept of taste being limited to the tongue is a massive oversimplification. The real magic, the thing that creates the rich, vibrant, and memorable experience of eating a perfect meal is something called flavor. And flavor is a full-blown sensory illusion created by your brain. The most important partner to your sense of taste is your sense of smell. In fact, scientists estimate that up to 80 or even 90% of what we perceive as flavor is actually derived from aroma. This happens through a process called retronasal olfaction. When you chew your food, you release volatile aromatic compounds. These lightweight molecules don't just stay in your mouth. They travel up the back of your throat into your nasal cavity, where they hit millions of olfactory receptors. This is why when you have a stuffy nose, food tastes incredibly bland. Your taste buds are working just fine. You can still tell if something is sweet or salty, but you've lost the nuance. You can't tell the difference between a cherry candy and a strawberry candy because the distinguishing cherry and strawberry notes are aromas, not tastes. Your brain is a master integrator. It takes the basic taste signals from the tongue, sweet, salty, sour, bitter, umami, and fuses them so seamlessly with the aromatic signals from your nose that you can't tell them apart. You perceive it as one unified experience, flavor. The raspberry in your yogurt isn't a taste. It's the combination of the taste sweet and the taste sour from your tongue, plus the specific raspberry aroma detected by your nose. And the brain doesn't stop there. It pulls in data from all your other senses to build the final flavor profile. Think about texture, which is really your sense of touch at work in your mouth. The difference between a crispy potato chip and a soggy one is immense, even if the basic salt taste is the same. The creaminess of an avocado, the chewiness of a gummy bear, the crunch of a fresh apple, these are all critical components of flavor. This sense is called somatosensation. Then there's temperature. A hot cup of coffee has a completely different flavor profile than a cold brew made from the exact same beans. The heat changes how we perceive both the taste and the aroma. What about pain? That might sound strange, but the burning sensation from chili peppers or the cooling effect of mint are also part of flavor. These sensations are triggered by compounds like capsaicin and menthol, which activate temperature and pain receptors in our mouths. Your brain weaves this information into the overall experience, turning a simple meal into an adventure. Even your hearing gets involved. Scientists at Oxford University have conducted experiments showing that the sound a food makes when you bite into it can alter your perception of its flavor. People rate potato chips as fresher and crispier if they hear a louder crunch when they eat them. The sizzle of fajitas arriving at your table or the pop of a champagne cork are not just background noise. They are the opening act of the flavor experience, setting expectations in your brain. All of this information, taste from the tongue, aroma from the nose, texture and temperature from touch, even sound from the ears, is synthesized in the brain to create the final, singular, and beautifully complex perception of flavor. So we started our journey in a classroom, looking at a simple, color-coded map. It was a world of 4 tastes, each confined to its own little country on the surface of the tongue. It was a story of neatness and order. But by pulling on that single thread of doubt, by asking why we can taste salt on the tip of our tongue, we unraveled that map and discovered a far more magnificent world. We found not 4, but 5 basic tastes. We learned that they aren't cordoned off, but are detected by every taste bud working in unison. We traveled back in time to a German lab in 1901 and then to a Harvard office in 1942, where we saw how a subtle scientific finding was flattened into a simplistic diagram that would mislead generations. This is a classic example of a half-truth. It wasn't a malicious lie, but a misinterpretation that became dogma because it was easy to understand and even easier to teach. The real story, as it so often is, was messier, more complex, but ultimately so much more interesting. Correcting this myth matters because it fundamentally changes how we think about food, our bodies, and the nature of perception itself. It reminds us that our experience of the world is not a simple one-tune recording of reality. It is an active construction, a story our brain tells itself by weaving together information from all of our senses. The tongue map gave us a false sense of simplicity. The truth gives us a profound sense of wonder. It elevates the act of eating from a simple chemical process on the tongue to a full-body, multi-sensory event orchestrated by the brain. It teaches us that flavor is not just in the food, it's in the sizzle, the aroma, the color, the texture, and the memory. The simple map on the wall is gone, replaced by a dynamic, interconnected network that explains why a single bite can evoke a memory, change a mood, or define a culture. The real map of taste isn't on our tongues, it's inside our heads. Now you know the real story. What other half-truths are still out there? If you enjoyed this episode, please subscribe, leave a comment, and join us next time. Until then, stay curious.